Hi everyone! Welcome to the course Git for Beginners. My name is Thomas Claudius Huber. Hi, I'm Thomas and I'm your instructor in this course. I am a professional software developer since 2001 and I've been using Git for many years. Git is one of the most popular version control systems that you can use to track the changes in your source code and to work together with other developers on your projects. In this course, you will learn Git from scratch. This means you don't need any prior knowledge about version control systems or about Git. You even don't have to be a software developer to watch this course. Now, let me show you the course outline so that you know what you can expect from this course about Git. First, I will ensure in this course that you understand the Git basics. You will learn what version control systems are and how they work. Then I will ensure that you know that Git is a distributed version control system and you will learn what that means. Next, you will learn how to work with Git locally on your machine. I will show you how to set up Git and then you will create and use a so-called repository. A repository is like a database that stores the changes of your source code. You will also learn how to branch and merge your code so that you can work on features without affecting the main code in your repository. Finally, you will learn in this course how to push your code to GitHub. You will learn how to work with remote repositories and I will show you how to create and merge so-called pull requests. Please don't be afraid if you are not familiar yet with terms like branch, repository or pull request. You will learn about all of this in this course. By the end of this course, you will know how to use Git to track and store the changes of your source code. I hope you will join me to learn Git together with me in this Git for Beginners course. I am Thomas and I'm looking forward to seeing you in the next lesson. Welcome to the lesson Understanding the Git Basics. My name is Thomas Claudius Huber. In this lesson, I will ensure that you have the foundational knowledge about version control systems and about Git. Let's take a look at the lesson outline. First, let's answer the question, what is a version control system? After you understood this, I will ensure that you know the different types of version control systems that exist. You will learn about local, about centralized, and about distributed version control systems. Finally, I will ensure that you understand the origin of Git. You will learn why Git was created and what requirements it fulfills. Now let's start and let's ensure that you understand what a version control system is. What is a version control system? To answer this question, it can be helpful to see what it looks like when you work without a version control system. Usually, when you start a new software project, you create a folder for your project. You put your code files and your whole project structure into that folder. Now, you might reach a point where you want to save the current state of the project. A reason can be that you want to create a release, or for example, you have implemented a complicated feature and you just want to store the state. Without a version control system, this means that you might rename this folder to My Project version 1 and then you copy the whole folder to another folder that you might call My Project version 2. Then you continue developing in that version 2 folder. At some point, you might again want to store the current state of your source code. This means you end up with another version folder. This copy approach actually means that you handle the whole versioning of your source code on your own. This copy approach has also many disadvantages. It is hard to see the differences between the separate versions. it is complicated to work isolated on different features, and it is nearly impossible to work together with other developers by using that copy approach. Also, sometimes it is hard to find out which is actually the latest version. I mean, here in this example, we have at least nicely named folders. But in the past, I have also seen people creating folder names like this. Here, it is super hard to know which is the latest version of your source code. Is it the folder new or is it the folder newer? You don't know and you have to find out. By using a version control system, these issues cannot happen. This is because the version control system handles the versioning of your source code. A version control system is a tool that helps you as a software developer to track and save all your code changes. This means that you don't have to copy anything around to save the current state of your source code. Instead, the version control system stores all the changes for you. Now, what you should know in addition is that instead of using the term version control system or just version control, you can also use the term source control. This is because version control actually means that you want to control the changes that you made to your source code. Alright, in the next clip, I will ensure that you know the different types of version control systems. Then you will learn a bit more how a version control system actually works. Let's ensure in this clip that you know the different types of version control systems. This knowledge is important for you to understand how Git works. There are actually 3 types of version control systems: local, centralized, and distributed. Git is a distributed version control system. To understand what a distributed version control system actually means, let's look at these 3 types, and let's start with local version control systems. In a local version control system, you have a so-called version database on your computer. This version database stores different versions of your source code. From that version database, you can get a file for a specific version. This is also known as a checkout. Of course, if you have a whole folder structure with multiple files, you get that whole structure for a specific version. In this case here, let's assume we have just a simple file and you can grab it with a specific version from the version database. Now, important to understand is that all of this happens locally on your computer. That is the reason why it is called a local version control system. It is powerful to track your code changes locally, but it does not support to work together with other developers on the same code base. Working together with other developers is where centralized version control systems come into play. With a centralized version control system, you have also a version database. But here, the version database is not stored on your computer. Instead, it is located on a central server. This central server is the reason why it is called centralized version control systems. On your computer, you can check out and work on a specific version of your source code. Another user can also check out a version of the source code. This means that with this centralized version control system, you can now work together with other developers on your projects. But as you can see, on your computer, you have only a specific version. To look, for example, at the history of your source code, or to save changes to your source code, you need a connection to the server. This means without the server, you cannot use the features of the version database. And this is exactly the point where distributed version control systems enter the stage. In a distributed version control system, you have also a server, but let's call that not central server, but instead server computer. It is just another computer that has the version database. Now, on the client computers, you don't check out a single version of the source code. Instead of this, you copy the whole version database to your computer. So, you can see the version database is distributed across multiple computers. This is the reason why it is called a distributed version control system. Now, as I mentioned already at the beginning of this clip, Git is a distributed version control system. In Git, the version database is called a repository. The different versions are identified by commits. A commit means that you saved a change of your source code. When you copy the repository from the server to your computer, it means in Git terms that you clone the repository to your machine. Now, the user on computer 2 can also clone the repository from the server computer to their machine. So, you see, the repository is not only on the central server, instead it is distributed to the different computers. To work now with the source code, the user on computer 1 can check out a specific version from their local repository. The user on computer 2 can also check out a specific version from their local repository. Having the repository locally means that a user does not need the server to work with the repository. They can browse the history, they can check out different versions, and they can even save changes. And all of this is possible without using the server. Let's say now that the user on computer 2 creates a new commit to save some changes to the source code. Next, they can push their local repository to the remote repository on the server. After this push, the remote repository on the server will also have that new commit. The user on computer 1 can now pull the changes from the server, and then they will have that new commit also in their local repository. So, this is the coding flow with a distributed version control system like Git. In this course, you will learn about cloning a repository and about pushing and pulling changes. The server computer that we will use is GitHub.com. There you can create remote repositories for free. But before working with a remote repository on GitHub.com, you will learn how to work with Git locally on your machine. With Git, you can start with a local repository and you can commit your changes there and learn how to use Git on your machine. At a later stage, you can push your local repository to a remote repository, for example on GitHub.com. This is actually what we will do in this course. Alright, now you learned about the three types of version control systems: local, centralized, and distributed. In the next clip, let's ensure that you understand the origin of Git. To understand the origin of Git, we must take a look at the development of the Linux kernel. The Linux kernel is the core of the Linux operating system. Linux was released in 1991. Back then, they didn't use a version control system. Changes to the source code were applied via patches and so-called archive files. A developer could send a patch to an online group, and then Linus Torvalds, the creator of Linux, applied the patch to his own source code. This means that applying changes required quite some effort and planning. In 2002, Linus Torvalds decided to use BitKeeper to manage the Linux kernel code. BitKeeper is a distributed version control system. But at the same time, BitKeeper is also a commercial product and it is not open source. How could that fit with the Linux kernel, which is a huge open source project? In fact, it didn't turn out well, and in 2005 it came to the break between the Linux community and the company who developed BitKeeper. This was the point when Linus Torvalds decided to develop his own version control system for the Linux kernel. And so he and the Linux community came up with some requirements for that new version control system. It should be fast and also simple. It should be free and open source. It should be a distributed version control system, and it should allow strong non-linear development. This means that developers can work on different features in isolation without touching the main source code. Of course, it should also support large code bases like the Linux kernel. But the fact that it should be simple means that it should work also super well for small projects. So, these requirements and a few more made it into the distributed version control system that we know today as Git. Linus Torvalds and the Linux community were really fast, and Git was released already in the year 2005. So, you see, Linux is actually the origin of Git. Now, you might wonder, why the name Git? What is the meaning of this name? Git is actually British slang for a bad person. When Linus Torvalds, the creator of Linux, was asked this question, he said, "I am an egotistical bastard and I name all my projects after myself. First Linux and now Git." This is of course a super ironic statement. When you look at the history of Linux, you will find out that Linus Torvalds wanted to call the operating system Freaks. Others convinced him to name it Linux, as that seems to be the better name. And now, with Git, the bad person, he made this very famous quote. But actually, there were some really important reasons for the name. It is short and it is very easy to type on a keyboard. It is also easy to pronounce and it is unique. But most importantly, Git was no standard command on the console. These reasons made the name Git perfect for a command line tool. Alright, so far to the origin of Git. Now let's wrap up what you have learned in this lesson. You learned in this lesson that a version control system tracks the changes of your source code. It handles the versioning of the source code for you. You learned that there are three types of version control systems: local, centralized, and distributed. Git is a distributed version control system. This means that the version database, respectively the so-called repository, is stored not only on the server, but on every computer. This allows you to execute many operations locally, like for example browsing the history or saving your changes with a commit. In the last clip, I also ensured that you understand the origin of Git. Git was created in the year 2005 to manage the source code of the Linux kernel. Now you have a foundational knowledge of distributed version control systems and of Git. In the next lesson, you will learn how to set up Git on your machine. Welcome to the lesson Setting up Git on your machine. My name is Thomas Claudius Huber. In this lesson, you will learn how to install and configure Git on your computer. Let's take a look at the lesson outline. First, I will show you how to install Git on your machine. After that, you will learn how to configure a username and an email. Without this information, you are not able to commit to a repository. This is because Git will store your configured username and email with every commit that you create. Now let's start and let's install Git on your machine. In this demonstration, you will learn how to install Git on your machine. Let's switch to my browser. Here in my browser, I have already entered the address git-scm.com. SCM stands for Source Control Management, which is a synonym for Version Control System or Version Control Management. Now let's hit Enter to navigate to this site. On this site, you find information about Git, you find documentation and downloads. Here on the right side, you find the latest source release. You can download for Windows and you can also download for macOS. Here I am on a Windows machine, so let's click here on the Download for Windows button. This brings up the download page for Windows that contains different options to install Git on your machine. You can use, for example, the win-get tool, which is the package manager on Windows. I just click here on this link to download the latest 64-bit version of Git for Windows. Now let's start here that downloaded executable file. I click on Yes to allow this application to make changes to my computer. Let me close the browser window in the background. Now here in the wizard, let's click on Next and let's keep here the default location to install Git under C Program Files Git. Let's click on Next. Here you can select different components that you want to install. I just keep the default here and I click on Next. Let's keep Git for an entry in the Start menu folder and let's click on Next. I also keep here Vim, which is the text editor for Git on Windows. When you expand this, you can select here another editor on your machine. I just keep here Vim as a default and I click Next. Then here, with this option, you can adjust the name of the initial branch in new repositories. Every repository has a default branch that gets created when you create the repository. That branch name is currently master, which is a non-inclusive term. Let's select here the option to override the default branch name for new repositories, and let's use here the suggested name main. This means when you create a new Git repository, the default branch name will be main. When you look at other repositories, you might still see that master is used as a default branch name. Now let's click on the Next button. Let's keep here the option Git from the command line selected so that we can use it from the Windows terminal. Now let's click the Next button and let's use the default values for all the other options that you can configure with this wizard. Finally, you reach the last page and you see here the Install button. So now let's click on this button to install Git on your machine. Now you can see the installation went through, so let's uncheck here View Release Notes and let's click on Finish. Now let's bring up a command line window. To do this, let's go to the Start menu. Here you can type cmd and you can open up a command prompt. Or if you have PowerShell installed, you can type here PowerShell and you can open up the Windows PowerShell. In my case, I have installed the Windows Terminal application that you find in the Microsoft Store. So let's open this application. Now on this command line, let's type here git, which is the command that is now available. Let's hit enter to execute this command. Now let's scroll up again to the top. As you can see here, these are common Git commands used in various situations. You find here the clone command to clone a repository, and you find the init command to initialize an empty Git repository. As you can see here, you can write git -h or --help to get help. you can write git-v or -- version to see the installed version of Git on your machine. So let me scroll down and let's type here cls to clear the screen, and now let's write git-v, and you can see on my machine I have installed Git version 2.37.1. Now Git is installed, so the next step is to configure it. In this demonstration you will learn how to configure your username and your email. Without this configuration, you won't be able to commit to a repository. This is because Git adds your configured username and your configured email to every commit that you create. So now let's switch to my terminal and let's configure this. To configure Git, you use the git config command. Let's hit enter to take a look at the options of this command. When you scroll up, you can see here there is a -l or --list option to list all the configuration. At the bottom, you see also that there is a --show -origin option to show the origin of the configuration. So let's clear the screen here by typing cls, and let's write again git config, and this time let's use this -l option to list the configuration. I press enter, and now you can see here my Git configuration. These are actually the options that you selected in the previous clip when installing Git on your machine. So down here at the bottom, you can see, for example, that we have set the default branch name to main. Now let's take a look where this configuration is actually stored. Let's clear the screen again, and now let's type git config -l, and now let's use that --show -origin parameter. I hit enter, and now you see the same information, like here for example, the default branch name, and in front of this, you can see the file where that configuration is stored. As you can see, it is under C program files git, which is the installation directory that we selected in the previous clip. Now let's take a look at this git config file. So I copy this path, and on Windows, let's use Notepad to take a look at this file. Let me use quotes here to define that path, and now let's hit enter. Now you see that git config file opened up in Notepad. So you can see and change here the configuration that you have defined with your Git installation. So here at the bottom, you can see again the default branch name that we have set to main. Alright, now let's close this again, and let's define now your username and your email. So let me clear the screen again. To configure that information, you use again the git config command. Now let's use the --global parameter to define your username and your email globally on your machine. This means that it will be used for every commit that you create on this machine. To define the username, you write user.name, and now in my case, let's write here Thomas Claudius Huber. Now I hit enter to store that configuration. Now I press the arrow up key to use that command again, and this time let's configure the user email. So I type in here my email address that is now used for every commit that I create on this machine. Now let's hit enter to also store this configuration. Of course, on your machine, you should use your name and your email address. So now everything is set up. Now let me press the arrow up key a few times to navigate back here to the git config command that shows all the configurations with their origins. Let's hit enter, and now you see here at the bottom the username and the user email. As you can see, this information is stored in my user directory in a .git config file. So now let's also take a look at this git config file. I copy this path, and again let's open this path in Notepad. Let's hit enter. As you can see now, here we have that entry for the user. The name is Thomas Claudius Huber and the email is thomas@thomasclaudiushuber.com, exactly like we configured it with the command line. Great, so now Git is installed and configured on your machine. Now let's wrap up what you have learned in this lesson. You learned in this lesson how to install Git on your machine. I showed you that you can download Git for your operating system from git-scm.com. In the last clip, you learned how to configure your username and your email with Git. You used the global parameter, which means that this configuration is stored in your user directory in a git config file. Git will add the configured username and email to every commit that you create. So now Git is set up and configured on your machine. In the next lesson, you will learn how to use Git to work with local repositories. Welcome to the lesson Working with Local Repositories. My name is Thomas Claudius Huber. In this lesson, you will learn how to create a local repository and how to commit changes to that repository. Let's take a look at the lesson outline. First, you will learn in this lesson how to use Git to create a local repository for your project. Next, I will ensure that you understand the three main areas that you use when working with Git. These are the repository, the working directory, and the staging area. After you are familiar with these three areas, you will learn how to work with your repository. You will learn how to create your first commit, how to look at the history of your code, and how to ignore files in the working directory so that you don't commit these files to the repository. Now let's start and let's create a local Git repository for your project. In this demonstration you will learn how to create a local repository. Let's switch to the command line. As you can see, the command line is on the D drive of my computer. Now let's create a folder for our project. To do this, let's use the make directory command and let's call the project just my project. Now I press enter to create this directory on my computer. Now let's use the cd command to change directories and let's go into that new my project directory. Let's also open that directory in File Explorer. So I type here Explorer and a dot for the current directory and now let's hit enter. This brings up File Explorer with this My Project folder that we just created. As you can see, this folder is empty. Now let me move File Explorer to the left side of my screen and the command line to the right side. In the command line, I type CLS to clear the screen. Now we have our My Project folder and the next step is to create a new Git repository in this folder. To do this, you use the git init command. This command will initialize an empty Git repository. Let's hit enter and you can see it says here initialized empty Git repository in d myproject.git. The repository is actually here in this .git folder. You can take a look into this folder and you see the Git internals. This folder is actually your version database, respectively the repository. You shouldn't change anything in this folder. It's pretty much like a black box. So let's navigate again one level up to our project directory. Now, important to mention is that this .git folder is a hidden folder. You can see it in my File Explorer because I have turned on the option to show hidden files and folders. Let's click here on these three dots to open up the folder options of File Explorer. when I navigate here in the options to the View tab, you can see I have selected here Show Hidden Files, Folders and Drives. When you select here Don't Show Hidden Files, Folders and Drives, and then when you click on Apply, you can see now this My Project folder seems to be empty, because now you cannot see the hidden .git folder. Let's select again Show Hidden Files, Folders and Drives, and let's click on Apply, and now you can see that hidden Git folder that contains the repository. Alright, so now we have created this My Project folder on the D drive that contains now an empty Git repository. Before you will create your first commit in this repository, I want to ensure in the next clip that you understand the three main areas when working with a Git repository. In this clip, let's ensure that you understand the three main areas that you use when working with Git. In the previous clip, you created a project folder for your project. In this folder, you initialized a new Git repository, which is the version database for your source code. You learned that the Git repository is in a hidden Git folder. Now, when you work with Git, you have beside the repository the so-called working directory. The working directory is actually everything that you have in your project folder beside the hidden Git folder. So, your working directory contains the source code that you have checked out from the Git repository. Of course, when you create an empty repository like we did in the previous clip, there is nothing to check out yet. Now we have actually two areas, the repository and the working directory. But when you want to commit the changes from your working directory to the Git repository, a third area gets involved. That area is also part of the hidden Git folder, and it is the so-called staging area. When you have changed files in the working directory, you can add those files to the staging area. Everything that you added to the staging area will be part of the next commit. So, these are the three main areas that you need to know when you work with Git: the repository, the staging area, and the working directory. When you have changed multiple files in your working directory, the staging area allows you to commit only a subset of the changed files to the repository. So this is the idea of the staging area. It allows you to define what goes into the next commit. Alright, in the next clip, you will create a file in the working directory, and you will learn how to add that file to the staging area and how to commit it to the repository. In this demonstration, you will learn how to create your first commit. Let's switch to my command line. In the previous demonstration, you used the git init command to initialize an empty Git repository in the D My Project folder. So here in this My Project folder, you can see now this .git folder, which is the repository. Now, when you run on the command line the git status command, you can see you are on branch main, which is our default branch name for new repositories, and there are no commits yet. Git suggests here to create copy files and use git add to drag. Git add is actually the command to stage files. So now let's add a file to our working directory. To do this, I right-click in File Explorer and I select from the context menu New Text Document. Let's create a README text file. Now let's make the window of File Explorer a bit smaller and let's open the README text file. As you can see, it opens up in Notepad++, which is the default text file editor on my machine. Now let's write in this text file the text "Welcome to my project." I press Ctrl S to save this. Now on the command line, let's use again the git status command. Now you can see untracked files readme txt. Nothing added to commit, which means nothing added to the staging area, but untracked files present. Use git add to track. So let's type cls to clear the screen, and now let's add that readme text file to the staging area. To do this, you use the git add command, and you can specify the file. Instead of specifying here the file name, you can also write a dot that identifies the current directory. This command will add all the changes in the current directory to the staging area. Changes in subdirectories are included as well. Usually, I use git add with a dot to fill the staging area. Now let's hit enter and let's write git status again. Now you can see Git says here changes to be committed, and there is this new file readme txt. This means the staging area has now that file. To commit it to the repository, you use the git commit command. A commit needs a message, and you specify that message with the m parameter. So in this case here, let's write create readme file. Now, before we execute this commit command, I want to mention one more thing that is not super important, but good to know. You write the commit messages in present tense in Git. So you don't write here created readme file. This is because you shouldn't describe what you did, but you should describe what this commit does. So let's just write present tense and let's use create readme file. Now let's put the cursor to the end of this line and let's hit enter to create the commit. Great! So now you have created your first commit. When you write again git status, you can see on branch main, nothing to commit, working tree clean, which means that the working directory does not have any changes. In the next clip, let's create another commit, and I want to show you a few more things. In this demonstration, you will create another commit to the Git repository, and you will learn a few more things how Git actually works. Let's switch to the command line. In the previous clip, you created here this commit for the readme file. Then you used here the git status command, and you can see we are on branch main and the working tree is clean, which means we don't have any changes. Now let's change here the readme txt file and let's add an author. I just keep it like this and I press Ctrl S to save this file. Now in the command line, let me type cls to clear the screen. Now let's write here again git status, and you can see on branch main changes not staged for commit. So here we have that modified readme txt file. Now let's use again the git add command with a dot to add that readme txt file to the staging area. Let's use again the git status command, and you see now changes to be committed is that modified readme txt file. So now you could use the git commit command to execute the commit. But before we do this, I want to change that readme txt file again. Let's add here Thomas as an author and let's press Ctrl S to save this. Now in the command line, let's clear the screen and let's type again git status. Now you see here two things. You see changes to be committed, which is the modified readme file, and then you see also changes not staged for commit, which is the modified readme txt file. This is because after we staged the readme txt file, you modified it again. So you see, when you stage a file, Git will put the current state of that file into the staging area. When you do further changes to that file, they are not included in the staging area. They are now here with this modified readme txt file. that you have to stage again to have all the changes in the staging area. Before we do that, I want to show you how you can actually look at the differences. You can use git diff and you can specify here a file if you want. Let's hit enter, and now you see the word author was removed. This is this minus, and here the word author and Thomas was added, which is here this green plus. Let me type CLS again, and let's write just git diff, and this will show you all the differences of your working directory to the repository. So as we just modified the readme.txt file, we see exactly the same thing. Now let's type CLS again. What you can also do is write git diff -- staged to see the differences between the staging area and the Git repository. So if you do this, you can see in the staged readme.txt file, you removed this welcome to my project line and you added that line again and also here the word author. Now you might wonder why that welcome to my project line was removed and then added again. This is actually because you added a line break at the end of this line with a change. You see here the message that there is no new line at the end of our README file. If you include a new line at the end of the README file, the diff looks a bit less noisy. Anyway, let's keep it here like this. Now, with this diff command, you can see that this is the change that is staged for the next commit. Note that the author name Thomas that we have specified here in the README file is not part of the staged change. Now let's write git add again, and let's add a dot to include everything of our working directory. And now let's type here git status. Now you see we have the modified readme.txt file and all the changes are now in the staging area. This means when you now type git diff -- staged, you can see now here that we have now author Thomas, which is actually exactly what we entered here. Alright, now let's write here git commit to commit that change. Now I want to show you one more thing. Let's omit here the message parameter and let's write just git commit. Let's hit enter. This opens up now Vim, which is the editor that you specified in your Git installation. Now you can use this editor to enter here a commit message for your changes. The question with this editor is always how to exit it. Of course, you can just close your terminal. Instead of doing this, you can type colon, you see it here at the bottom, and then a Q for quit. Now let's hit enter, and you see we are again on the command line, and the commit was aborted due to empty commit message. Even after your Git installation, you can specify another editor for Git. To do this, you can use the git config command. Let's write here -- global to define the editor globally, and now let's set the core editor property. Here on Windows, let's just set it to Notepad. Now I hit enter to store that information. Let's write git config -l to list the configuration, and now you see here core editor Notepad. Now let's clear the screen again, and now when you write just git commit and when you hit enter, you see here Notepad opens up, and now you can enter here a commit message. After entering the commit message, you can close Notepad, and then that commit message will be added to the commit. Using an editor can be helpful if you want to write more complex commit messages. But here in this course, let's use the -m parameter to specify a message. So I just close here Notepad, and now you see the commit was again aborted because the message was empty. Now let's write here git commit, and let's use again that -m parameter. What does the commit actually do? It adds here the author. So let's write here add author to readme. Let's put the cursor to the end and let's hit enter to create this commit. Now let's write again git status and let's hit enter, and you see we are on the branch main, nothing to commit, our working directory is clean. Alright, in the next clip I will ensure that you know what snapshots are, and after that we will take a look at the history of our repository. In this clip I want to ensure that you know what snapshots are. To make it clear from the beginning, a commit in Git is actually a snapshot. But what is meant by snapshot? Let me show you this in this clip. Let's say you created in your working directory 3 files. You also initialized an empty Git repository. Now let's assume you staged these 3 files and you created your first commit. With the commit, Git creates a snapshot of all your files. This means that Git records the current state of your files, and this is what the word snapshot actually describes. Then Git stores that snapshot in the repository. There, the main branch will point now to this snapshot, respectively to this commit. Now let's assume that after this commit, you modify the file2 in your working directory. Next, you stage and commit that file. With this commit, Git does not only record the change of that single file. Instead, Git creates again a snapshot of all your files. So, you see, the term snapshot describes actually how a commit in Git works. With a commit, a snapshot of all your files is taken, which means that the current state of all your files is recorded and stored. So, that new snapshot is also stored in the repository, and then the main branch is changed automatically so that it points now to that new snapshot, respectively to that new commit. When you change now, for example, file 1 and file 3, and when you stage and commit your changes, Git creates another snapshot. Again, that snapshot is stored in the repository, and the main branch is moved to point to that new snapshot. Now, as I mentioned already, the term snapshot means in Git actually a commit. So it is the same thing. But now you know, when you come across the term snapshot, what it actually means. It means that Git does not store single file differences with a commit. Instead, Git creates a snapshot of all your files with every commit. Now, important to know is that Git creates for every snapshot, respectively for every commit, a hash value. That hash value is a 40 characters long string that looks similar like this one. Such a hash value identifies a snapshot, respectively a commit. This means that the hash value can be used to check out a specific commit from your repository. Checking out a specific commit can be useful when you look at the history of your code. Then you can see what was actually the state of your code with that commit. In the next clip, you will learn how to do this. You will learn how to look at the history of your code and how to use the hash value to check out a specific commit. In this demonstration, you will learn how to look at the history of your code. Let's switch to the command line. In the previous clips of this lesson, you have created 2 commits to our repository. You can take a look at these commits by using the git log command. Let's hit enter, and now you see here the 2 commits, create readme file and add author to readme. As you can see, the commit includes your configured username and also the configured email address. Also here, you can see the snapshot hash value of the commit. Now, the git log command has also a pretty parameter that you can set to one line. Let's hit enter, and then you see the commits nicely on one line. I have a line break here because my window is not big enough. When I make this terminal window bigger, you can see exactly one line per commit. Now let's make it smaller again. Now let's say that you want to take a look at this first commit. To do this, let's copy here the first few values from the snapshot hash. You don't have to copy the whole hash, as these few values are already enough to identify the commit. Now you can use the git checkout command, and then you just use these values of the snapshot hash. Now let's hit enter, and it says here you are in detached head state. This means that you are not on a branch anymore. You have checked out a commit from the history. Now, when I put the cursor into Notepad++, it says here that the file has been modified by another program. Do you want to reload it? I click yes, and now you can see with that commit we had just the text "Welcome to my project" in the README file. Now on the command line, let's type CLS again. So you used now this checkout command to check out a specific commit. Instead of using here the hash value, you can also specify a branch name to check out a branch. So let's check out again the main branch and let's hit enter. Now you can see you switched to branch main. You can check this again by using the git status command. Here you can see that you are now again on the main branch. This means when you put the cursor again into Notepad++, it says again that the file has been modified by another program. Do you want to reload it? Yes, of course. Let's reload it. And now you see here again the author information in this file. So now you learned how to take a look at the history of your code. In the next clip, I will show you how you can ignore files in your working directory. When you use Git in your software development project, there are usually several files that you don't want to commit to your repository. This means you want to ignore these files that are located in your working directory. These files can be, for example, the compiled output of your source code. You can get this output by compiling the source code. So there is no need to commit this compiled output to your repository. Another example are generated files. If you can generate, for example, configuration files from your project, there is no need to commit these files to the repository. Another example are third-party packages that get downloaded when you build your project. For example, in a Java project, you might have configured Maven. In a .NET project, you have so-called NuGet packages. And in a Node.js project, you have Node modules. You don't want to commit all these packages to your repository because they get downloaded as an external dependency when you build the project. So you should just commit your source code to the repository. To ignore all these things that you don't want to commit, you can create a so-called git ignore file. You put this file in your working directory. Let's take a look how to define the content of such a file. With star.txt, you can ignore all the text files in your working directory. This includes also text files in subdirectories. As you can see also here, with a hash, you can add a comment in this git ignore file. With an exclamation mark, you can say, hey, but please do not ignore the readme.txt file. With a slash, you can identify the root folder. Here you say, ignore only the txt files that are in the root folder. Maybe you want to ignore files in specific folder types. So here, all text files in folders with a name generated are ignored. You can put 2 stars into the path to include also subdirectories. So this will ignore all the text files in all generated folders, including their subdirectories. If you want to ignore all the files in folders with a name generated, you can just add that folder name to the git ignore file. There is much more about this git ignore file, and you can read it in the Git documentation. Now, in this demonstration, I just want to show you how you can ignore files in the working directory and what it actually means. Let's switch to my command line. So here in our project, let's type git status, and you see we don't have any changes. Now, to see the effect of a git ignore file, let's just add here a new file to our working directory, and let's call that compiled output. Now, when you write on the command line git status, you can see this untracked file. But now let's assume this file contains actually the compiled output of our source code. This means you never want to commit this file. So let's ignore it. To do this, let's add here a git ignore file to our directory. So I write here .git ignore and I hit enter, and I'm sure that I want to call the file exactly like this. Now again on the command line, let's clear the screen and let's write again git status. Now you can see here that Git notices the git ignore file and the compiled output text file as untracked files in the working directory. Now let's right-click the git ignore file in File Explorer and let's open it with Notepad. Now let's add here a comment ignore compiled output. And now let's specify here the compiled output txt file. This means now that all files with the name compiled output txt will be ignored. This includes also compiled output txt files in subdirectories of your project. If you want to ignore only the file in the root folder, you can add a slash before this file name. Now let's press Ctrl S to save this git ignore file and let's close Notepad. Now here in the command line, let's write again git status. Now you can see here is only the git ignore file. The compiled output txt file is now ignored. This means now when you write git add dot to include all the files from your working directory, and when you then write git status, you can see that only the git ignore file was added to the staging area for the next commit. The compiled output txt file is ignored. So now let's create here a commit and let's write add git ignore file. And let's hit enter to create this commit. Now let's type again git status and you see you are on branch main. There is nothing to commit, the working tree is clean. So when you go to the compiled output file and when you enter here something, let's write this is the output and let's press Ctrl S to save this. And when you go again to the command line and when you write git status, you see this file is just ignored. So the git ignore file is the way to go how to ignore things that you don't want to have in your repository. Now let me bring up a browser window. Here you can see I'm on github.com/github/gitignore. In this repository, you find different git ignore files for different frameworks and programming languages. So when I scroll down, you can see here, for example, one for Android Studio, here is one for C++, here is one for C. So you can just look through this repository and take a look at the different git ignore files. Alright, so far to working with local repositories. Now let's wrap up what you have learned in this lesson. You learned in this lesson how to create a local repository by using the git init command. I showed you that the Git repository is stored in a hidden .git folder. I also ensured in this lesson that you understand the three main areas that you use when you work with Git: the repository, the working directory, and the staging area. Finally, you learned how to work with your local repository. You learned how to create your first commit, how to look at the history of your code, and how to ignore files in the working directory by using a git ignore file. Now you have a solid knowledge of using Git to work with a local repository. But so far, you worked only on the main branch of your repository. In the next lesson, you will learn how to implement a feature on a separate branch and how to merge the code of that separate branch back into the main branch. Welcome to the lesson Branching and Merging Code. My name is Thomas Claudius Huber. In this lesson, you will learn how to create a branch in your repository so that you can work isolated on a specific feature. Let's take a look at the lesson outline. First, you will learn in this lesson how to create a branch. Then you will implement a feature for our project in this branch. Next, you will learn how to merge the branch with the implemented feature back into the main branch. Finally, I will show you in this lesson how to handle merge conflicts. Now let's start and let's create a branch to implement a new feature in our project. In this demonstration, you will learn how to create a branch. Let's switch to my command line. Here in our repository, let's write git status, and you can see we are on the branch main. This is our default branch. When you work on bigger projects, you usually want to implement features isolated in your own branch. Then you are not affected if changes are applied to the main branch while you are working on your feature. To create a branch, you use the git branch command. Then you can just specify a branch name. Let's say the feature is to add a Twitter handle to this readme.txt file. So let's call the branch @Twitter-handle. Instead of calling it just like this, I usually use the prefix feature / and then the name of the feature, or if it is a bug, I use bug / and then the name of the bug. If you track your bugs and features in an issue tracking system, you have usually a unique number for your bugs and features. Then you could also use that number here instead of this name. This would allow you to make a connection from your branch to the issue in the issue tracking system. In this case here, let's call the branch just feature @Twitter-handle. Now let's move the cursor to the end of this line and let's hit enter. To see the branches, you just write git branch, and when you hit enter, you see now here our new branch and here also the main branch. The main branch is green and has a star in front of it because we are currently on that main branch. You see this here by looking at the status. To go now to the other branch, you use the git checkout command. Let's write here feature / @Twitter-handle. And now let's hit enter. Now you see here the message switched to branch feature / @Twitter-handle. This means when you write now git status, you can see that you are now on that feature branch. So now let's go to the readme file and let's write here Twitter and I add here my Twitter handle. I press Ctrl S to save this. Now let's go again to the command line. When you write now here git status, you can see we have that modified readme.txt file. So let's clear the screen and let's use git add to add that readme.txt file to the staging area. Now let's write again git status, and you see changes to be committed is that readme.txt file. So next, let's create here a git commit, and let's set the message to add Twitter handle. I hit enter to create this commit. Now let's look again at the status of our feature branch. As you can see, nothing to commit, the working tree is clean. So now you have implemented this Twitter handle feature on this feature branch. The next step is to merge this feature branch back into the main branch. Let's do this in the next clip. In this demonstration, you will learn how to merge a branch back into your main branch. Let's switch to the command line. In the previous clip, you created this commit here in the feature add Twitter handle branch. So now when you type git branch, you can see we are still on this branch. When you type here git log, let's use pretty equals one line, and let's hit enter, you can see here that commit to add the Twitter handle. Now you want to bring this commit also to the main branch. So as you just saw, currently we are here on the feature branch. To switch back to the main branch, you use again the git checkout command and then the name of the main branch. Let's hit enter and let's type in git branch again, and now you see you are here on the main branch. So when you write on the main branch git log, you can see you don't have that latest commit on the main branch. When I click in Notepad++ on this readme.txt file, you can see it wants to reload it because on the main branch we don't have that Twitter handle in this file, as we don't have this commit. Now let's clear the screen again and let's use the git branch command. So you can see we are here on the main branch, and to bring in the changes of this feature branch, you use the git merge command. Let me copy here the name of the feature branch, and now let's use it here for the merge command. This means now we are on the main branch and we want to merge in the changes of that feature branch. Let's hit enter to do this. As you can see, Git did a so-called fast forward, which means it just applied the commit of this feature branch to the main branch because there were no changes in the meantime on the main branch. If there would have been changes, the merge command would have created a separate merge commit. Now, when you click here into Notepad++, it wants to reload the readme.txt file. And now you see, now we have that Twitter handle also on the main branch. This means now, when you write git status, you see you are on branch main and there is nothing to commit. When you look again at the logs, you can see that now this new commit is also on the main branch. This means now that you can delete actually that feature branch as you don't need it anymore. To do this, you use git branch -d for delete and then that feature branch name. Let's copy it and let's hit enter. Now you see the branch was deleted. Let's write again git branch, and now we have only our main branch. Great! In the next clip, you will learn how to handle a so-called merge conflict. In this demonstration, you will learn how to handle merge conflicts. Let's switch to my command line. Here in our project, we are on the branch main, which is our only branch that we have right now. Now let's say we want to implement two features. We want to add the author's middle name and another feature, which is the author's last name. So let's use the git branch command to create a new feature branch. Let's call it just last name. I use the command again to create another branch for the middle name. This means now when you call git branch, you see those new feature branches. Now let's check out the feature last name branch. In this branch, let's add here to the author the last name and let's save this. Now let's go to the command line. Let's write git status. You see the readme file was modified. So now let's write git add and let's write again git status, and now it is staged. Now let's create a commit and let's write here add last name. Let's hit enter to commit this. Now let's write again git status, and you see we are on branch feature last name and the working tree is clean. The feature is actually implemented. So let's merge it into the main branch. To do this, I first check out the main branch. Now let's use the git merge command and let's merge in that feature last name branch. Before doing this, let's click into Notepad++ to reload it, and you see on the main branch we don't have the last name. Now let's execute here the merge command and let's go again to Notepad++. As you can see, it wants to reload the file. Let's do this, and now you have the last name also on the main branch. So now let's use again here the git branch command. The last name feature was merged. This means we can delete that feature last name branch as the feature is already in our main branch. Now let's use the git branch command again, and you see we have now only these two branches. Now let's implement actually the middle name. So let's use here the git checkout command to check out this feature middle name branch. Now on this branch, we don't have here the last name. So when I click into Notepad++, it wants to reload the file, and you see on this branch, we have just the first name. This is because we are actually one commit behind the main branch. Now let's implement the feature for this branch, which is the middle name. So I add it here and I save the readme file. Now let's use on the command line the git status command. As you can see, we have modified the readme.txt file and no changes were added to commit. So now let's use here the git add command and let's write again git status. Now you can see changes to be committed is the readme.txt file. So let's create here a commit and let's set the message to add middle name. Let's hit enter. Now let's look again at the status of this branch, and you see nothing to commit, working tree clean. We have added now the middle name to the author. Now let's merge also the changes of this feature branch into the main branch. So let's use here the git checkout command to check out the main branch. Let's write just git branch, and you can see we are on the main branch again. Now let me clear the screen and let's write again here git branch. So we are on the main branch. This means when you click here into Notepad++, you see that we have defined on the main branch the last name for the author. Now let's see what happens when we merge in that feature middle name branch. So let's use here on the main branch the git merge command to merge in this feature branch for the middle name. Let's hit enter. Now you see auto merge in readme.txt conflict merge conflict in readme.txt. The automatic merge failed, fix conflicts and then commit the result. Now when you click into Notepad++, you can see the file was changed, so let's reload it. Now let's make the Notepad++ window a bit bigger. As you can see, there are 7 opening angle brackets and then the name head, which defines the current point of our main branch. You can see here the author is Thomas Huber, so here the last name is defined. Then you see 7 equal signs, and then the content of the feature middle name branch, which is here the first name and the middle name. Then this is closed by 7 closing angle brackets and the name of that feature branch. So now you see, in both branches, we have modified here the author, and Git was not able to automatically merge this. But now for you as a developer, it is clear what you should do. You should just specify the middle name and the last name. So let's write here just Thomas Claudius Huber, and then let's remove all these special characters from this file. So this is how the readme.txt file should look like. Now let's make this again a bit smaller and let's save the changes. Now let's go to the command line and let's type here git status. Now you see you are on branch main, but you have unmerged paths. You can use git merge -- abort to abort the merge, or you can use git add to mark the resolution. Actually, we have resolved here all the conflicts in this readme.txt file. So let's write here git add to stage that readme.txt file. Now let's clear the screen and let's type again git status. Now you see you are still on branch main, all conflicts fixed, but you are still merging. Use git commit to conclude merge. Under changes to be committed, you find the readme text file. So now let's use the git branch command so that we can see here the branches again. And now let's create here a commit. Let's write here merge branch, and now I just copy here the branch name and I put that one into the commit message. Now let's hit enter to create this commit. Now let's clear the screen again and let's type here git status. As you can see, we are now on branch main, there is nothing to commit and the working tree is clean. When you click into Notepad++, you see it doesn't want to reload the file because this is now the state on the main branch. Now let's write on the command line again git branch, and now let's use git branch -d to delete this feature branch that you just merged into the main branch. So let's write git branch again, and you see now we have only that main branch. Now let's also take a look at the logs. Let's write here -- pretty equals 1 line and let's hit enter. You can see here now the different commits, and you can see here a so-called merge commit to merge the feature middle name branch. Let's clear the screen again and let's use this git log command again, but this time I add another parameter which has the name --graph. Now let's hit enter. This parameter shows you here a graph with the different commits. So you see here we added the Twitter handle. Then also on the main branch we have that add last name commit. This is directly on the main branch because Git was able to do a so-called fast forward because there were no other changes in the meantime. Then you created this add middle name commit on our feature branch, and in the meantime on the main branch we had that add last name commit. So you see both commits have the previous commit add Twitter handle. In the final step you created here a merge commit to bring together again these two different commits. So now we have again all the features in our main branch. Now let's wrap up what you have learned in this lesson. You learned in this lesson how to create a branch, how to implement a feature in this branch, and how to merge the branch back into the main branch. In the last clip, I also showed you how to handle merge conflicts. Working with branches allows you to develop features in isolation. While you work on your feature branch, you are not affected by anything that is changed in other branches, like for example in the main branch. Now you have learned quite a lot while working with your local repository. In the next lesson, you will learn how to push your local repository to a remote repository on github.com. Welcome to the lesson Pushing to a Remote Repository. My name is Thomas Claudius Huber. In this lesson, you will learn how to push a branch from your local repository to a remote repository on GitHub. Let's take a look at the lesson outline. First, you will learn in this lesson how to create a remote repository on GitHub. Next, I will show you how to work with that GitHub repository. You will learn how to push code to the repository, how to clone the repository to a local machine, and how to pull changes from the remote repository into your local repository. Finally, I will ensure that you understand the pull command, and you will see that it does a so-called fetch and merge behind the scenes. Now let's start and let's create a repository on GitHub. In this demonstration you will learn how to create a repository on GitHub. Let's switch to my browser. Here I've opened github.com. GitHub is for free, and if you don't have an account yet, you can sign up here with your email address. I have already an account, so let's click here on Sign In. My username and password are already entered, so I click on Sign In. Now I check on my phone the two-factor authentication code and I type in that code. Now in the top right corner, I click on my logo and I select here Your Profile. Now you can see here my GitHub profile, and you see here also my repositories. These are public repositories and also private repositories that you won't see when you navigate to my profile. Now, to create a new repository, you can use this plus here in the top right corner, and you see here a menu item, New Repository. Instead of using that menu item, you can also navigate here to your repositories. Here you find also a button that you can use to create a new repository. So now I just click on this button to create a new repository. Now you see the first thing that you need to define here is a repository name. So let's call the repository Git for Beginners -my project. You can also enter an optional description for that repository. Let's write here repository of Git for Beginners course. Next, you can choose here if your repository is public or private. Public means that anyone can see it, but you choose who can commit to the repository. Private means that you also choose who can actually see your repository. In this case, let's keep it public. Now let's scroll down. Next, you see here a section Initialize this repository with, and you can see you can add a README file, you can add a gitignore file, and you can select here from different templates for different programming languages and frameworks, and you can also select a license file, and you find here common open source licenses. Now, here is an important note that says skip this step if you are importing an existing repository. Actually, this is what we want to do. We want to import our local repository into this remote repository on github.com. So let's not choose here any of these options, and let's create the repository by clicking here on this button. Now you can see we are now on this URL github.com/Thomas Claudius Huber, which is my username, and then the name of the repository that we have defined. Now this remote repository is created. So in the next clip, let's push your code to this remote repository. In this demonstration, you will learn how to push your code to the remote repository on GitHub. Let's switch to my browser. In the previous clip, we created this Git for Beginners My Project repository on GitHub. You can see here actually instructions how to push your local repository to this remote repository. Here you see a README file is created, then a Git repository is initialized, then that README file is staged, then a commit is created, then the branch is renamed to main, and then this remote repository is added and the code from your local repository is pushed to this remote repository with the name Origin into a main branch. So actually, these two statements are the statements that you have to execute in your existing local repository to push it to GitHub. If you would push to another remote repository, it would just be a different URL here. You can copy the URL from here by clicking here on this button. Let's do this, and now let me bring up a command line window. Here I've opened the folder of our project. Let's write here git status to check the status. As you can see, I'm on branch main and there is nothing to commit, the working tree is clean. Now let's write here git remote to add a new remote repository. Let's add that remote repository under the name Origin. This is by convention the name that you use when you have just one remote repository. You could also add different remote repositories with different names. After the name, let's specify the URL that I just copied from github.com. Now let's hit enter, and now this remote repository was added. This means when you type now just git remote, you can see here that you have a remote repository with the name Origin. You can write git remote-v for verbose, and then you will actually see the two URLs that you can use to fetch changes from the remote repository and to push changes to the remote repository. There is also a command called git remote show, and then you specify Origin, and then you will also see that fetch and push URL. As you can see, the head branch is unknown. This is not defined yet, as there is nothing on GitHub yet. Now the remote is added, so let's clear the screen and let's push now our local repository to that remote repository. To do this, you use the git push command. Next, you specify the remote repository. Let's use here our Origin repository, and then you specify the branch of the remote repository into which you want to push. Now, for this command, there is another parameter that you should use, which is the -u parameter. This parameter stands for upstream. It associates this main branch of the Origin remote repository with our local main branch. This means when you use the git push command the next time, you don't have to specify Origin main anymore. I will show you this in a minute. Now let's put the cursor at the end of this statement and let's hit enter to push our repository to the remote repository. Now you can see that in the remote repository, the new branch main was created. Also, because you have used here this -u parameter, the branch main in our local repository is set up to track the Origin main branch from the remote repository. Now let me bring up the browser window again. Here in the browser, let's click on the refresh button to refresh this site. Now you can see here actually the code of our Git repository. Here is the gitignore file and the readme txt file, and here you can see also the content of the readme txt file. When you click here on these 7 commits, you can see here all the commits that we created in our local repository. Now let me show you how to create another commit. Let's bring up the command line again. Here on the command line, let's first clear the screen. As you know, in our directory we have here this readme.txt file. Now let's use here Notepad to open that readme.txt file. Let's write here on the first line, welcome to the Git for Beginners, my project. And let's save this. Now let's close Notepad. On the command line, let's check the status with the git status command. As you can see, we modified the readme.txt file and it is not staged for commit. So now let's clear the screen and let's use git add dot to stage that file. Let's check it again with git status, and now changes to be committed contains the readme.txt file. So now let's use here the git commit command and let's set the message of the commit to add course name to readme title. I hit enter to create that commit. Now let's clear the screen again. Now let's check again the status by using the git status command. You can see you are on branch main and you can see now that your local branch is ahead of the remote main branch by one commit. Use git push to publish your local commits. So now you can use here git push and you don't have to specify origin main anymore, because when you used this command previously, you used here the upstream parameter. This means you can remove that information and you can just write git push. Let's hit enter to do that. Now you see you pushed the changes to the remote repository. Before we take a look if we can see now that new commit, let's clear the screen again and let's call here git remote show origin. Now you see here a bit more information than before. Beside the fetch and push URL, you can see that the head branch, respectively the default branch of the remote repository, is the main branch. You see here the remote branch that is tracked, which is the main branch. You see also here what is configured to pull code from the remote repository and to push code to the remote repository. Alright, now let's bring up the browser again. Here in the browser, we are still looking at the commits. Now let's refresh this page. Now you can see here that new commit add course name to readme title. So you can even click here on this commit and you can see what was actually changed with this commit. We changed here the title to Welcome to the Git for Beginners, my project. So now, when you click again on the Code tab, you can see here that the readme.txt file contains now this new title. Alright, in the next clip, you will learn how to clone a remote repository to your local machine. In this demonstration, you will learn how to clone the remote repository to your machine. Let's switch to my browser. Here you can see our remote repository. Let's assume now that you have deleted the local repository from your machine and now you want to update here the readme.txt file of this repository. GitHub would allow you to edit it directly in the browser. But let's assume we have a more complex case that involves multiple files in your repository. Then you might want to copy this remote repository to a local repository on your machine. To do this, you click here on this code button and you see here the URL of this repository. This means you just copy here this URL and then you can clone that repository. Let's do this now from the command line. Here on the command line, let's use the make directory command and let's create a new directory with the name myproject_copy. Now let's use the change directory command and let's navigate into this myproject copy folder. Now let me clear the screen. Now to clone the remote repository into a local repository, you use the git clone command. So now here, let's just paste that URL that I just copied from the repository homepage on github.com. Now, important, when you call the git clone command like this, the command will create a Git for Beginners My Project folder that will contain the repository. But I want that the repository will be cloned directly into this My Project _ copy folder. To achieve this, you write here a dot to specify the current directory as a target for the clone command. Now let's hit enter, and now the repository is cloned into the current directory. Let's type here Explorer and dot to open up the current directory. Now you see we are here in the D My Project _ copy folder, and here you have the gitignore file and the readme.txt file. There is also the hidden .git folder that contains the cloned repository. Now let's change that readme.txt file. In this file, let's add a website. Let's write here thomasclaudiushuber.com, and let's press Ctrl S to save this file. Now let's close Notepad and also Windows Explorer. Interesting is, when you cloned a remote repository into a local repository, then the remote is already set up. So you see, here a remote repository with the name Origin is defined. When you type git remote-v for verbose, you can see here the URL of that repository. Also, when you type git remote show origin, you can actually see that the remote branch is already tracked. This means you can just use git push to push up your changes to the remote repository. But before doing that, you need to stage and commit the changes. So, when you write git status, you can see the readme file is not staged yet. So let's use git add to stage that file, and now let's create a commit. Let's write here add website to readme. And let's hit enter to create this commit. Now, when you write again git status, you can see your local branch is ahead of origin main by one commit. Now let's use the git push command to push that commit to the remote repository. So now, let's switch again to my browser. The browser shows here still 8 commits. Now let's refresh this page. And now you can see here 9 commits. Now you can also see that the readme file contains the website. When you go to the commits by clicking here on 9 commits, you can see here that add website to readme commit. Alright, so now you learned how to clone the remote repository into a local repository. In the next clip, you will learn how to pull changes from the remote repository. In this demonstration, you will learn how to pull changes from the remote repository into your local repository. Let's switch first to my browser. In the previous clip, you created this add website to readme commit. Now let's switch to my command line. You pushed that commit from the repository in this My Project _ copy folder. So let's show here the logs with git log -- pretty equals 1 line. By the way, instead of this, you can also write -- 1 line. Now you see here add website to readme is in this repository. But now let's look at the other repository that I have in the My Project folder. Let's switch to that folder and let's run in that folder the git log command. Here you can see we are here on that commit add course name to readme title. We don't have in this repository that latest add website to readme commit. To get this latest commit also in this repository, you need to pull the changes from the remote repository. So first, let's clear here the screen. Now we are in that My Project repository. First, let's open up Notepad with the readme text file. As you can see, the website is not here. Now let's close this again. Now to pull the changes, you use the git pull command. With this command, you can also specify the remote and the branch. This means now pull the main branch from the origin remote repository into the current branch that I have checked out locally. But as we have set this information as upstream before by using the git push command, you don't have to specify it here. You can just call git pull. So now let's hit enter to execute this command. As you can see, the git pull command grabbed the changes from our remote repository. In our local branch, it did a fast forward commit, and now you have the latest changes of the README text file. So that means when you now execute that git log command, you can see you have now also this add website to README commit. Now let's look again at the README text file in Notepad, and you see the website is now included. Great! So now you learned how to use the git pull command to pull changes from the remote repository into your local branch. In the next clip, I will ensure that you understand what the git pull command does behind the scenes. In this clip, let's ensure that you understand the pull command and how it works behind the scenes. In fact, the git pull command does a git fetch and a git merge. The git fetch command just grabs the changes from the remote repository but does not merge them into your local branch. With the git merge command that you know already from merging branches, you can merge the changes of the remote branch into your local branch. Now, instead of using git pull, let me show you how to use these two commands, git fetch and git merge. This is actually what git pull does behind the scenes. So, in this demonstration, you will learn how to use git fetch and git merge to fetch and merge commits from the remote repository into your local repository. Let's switch to the command line. Now you can see I'm here in the myProject_copy directory. Let's push a commit from this repository and then let's fetch and merge it from the myProject repository. So first, let's use here Notepad and let's open up the README text file. Here to the website, let's add the HTTPS protocol. And let's press Ctrl S to save this README text file. Now let's type here git status and you see it is modified. So let's stage that file and let's create a commit. Let's write here add HTTPS to website in README and let's hit enter. Now I type here git push to push that commit to the remote repository. Now let's clear the screen. Let's use here git log --one line to show the commits. You can see this directory contains here this latest commit that we just pushed to the remote repository. Now let's change directories and let's go into the myProject directory. Here in this local repository, you don't have that latest commit to add HTTPS to the website. So now, of course, you could use in this repository git pull to bring in the changes. But now, instead of using git pull, let's use git fetch. You can specify here also origin main, but as we have set the upstream, you don't have to specify it. Now let's hit enter to do this. Now you can see some changes were fetched. But when you look now at the log, you can see you don't have that latest commit that adds HTTPS to the website. This is because git fetch only downloads the latest state of the origin main branch, but it does not merge that origin main branch into our local main branch. When you take now a look at the status of your repository, you can see that your local branch is behind the origin main branch by one commit. Git suggests here to use git pull to update your local branch. As you know, git pull does a git fetch and a git merge. But instead of using git pull here to merge in the changes from the remote repository, let me show you how to merge in now the fetch changes with the git merge command. The question is, where does the fetch command actually store the changes? It stores the changes in a local copy of this remote branch. So let's clear the screen and let me show you this. When you type git branch, you can take a look at your branches. You see here only the local main branch. But you can use here git branch -a to show all branches, and now you also see that remote main branch. So locally, you have also a copy of the remote branches, and the fetch command actually downloaded all the changes into this local copy of the origin main branch. This means now that you can do a git merge, and you can merge in that origin main branch into the local main branch on which we are currently. As you can see here, the copy of the remote branch has a remotes prefix. This is the case for all the local copies of remote branches. When you use this branch with the git merge command, you don't specify that remotes prefix. Now let's hit enter to execute here the merge command. Now you see Git did a fast forward, and now the readme file was updated. So when I look now here at the readme txt file, you see it contains here HTTPS. Now let's close this again. Also, when you look now at the logs, you can see now you have that add HTTPS to website in readme commit in this local main branch. So you saw now, instead of using git pull, you can also use the separate commands git fetch and git merge. Git fetch is great to grab the changes from the remote repository, and then you can decide when is a good time for you to merge in these changes into your local branch. Git fetch is also great to just check if there are some changes in the remote repository. So if you call now git fetch, let's see what it does. You see it just returns nothing. If you call git pull, you see it says already up to date. Alright, now let's wrap up what you have learned in this lesson. You learned in this lesson how to create a remote repository on GitHub. After that, I showed you how to work with that GitHub repository. You learned how to push code from your local repository to the remote repository, how to clone the remote repository into a local repository, and how to pull changes from the remote repository into your local repository. In the last clip, you also learned that the git pull command does actually a git fetch and a git merge of the remote branch. If you want to download the commits from the remote repository without merging them into your local branch, you can do that with the git fetch command. Now you know how to work with a remote repository on GitHub. In the next lesson, you will learn what pull requests are. They are important when you collaborate with other developers. I will show you how to create a pull request on GitHub, and you will learn how to merge such a pull request into the main branch of your repository. Welcome to the lesson Creating and Merging Pull Requests. My name is Thomas Claudius Huber. In this lesson, you will learn how to use so-called pull requests to merge branches into your main branch. Let's take a look at the lesson outline. First, we will answer the question, what is a pull request? You will learn that a pull request is a way to say, please merge my branch with my new feature into the main branch. You will learn in this lesson how to create and merge a pull request on GitHub. I will also show you how to fork a repository on GitHub. you will learn that a fork is a repository copy that lets you create a pull request in someone else's repository. Now let's start and let me show you what a pull request actually is. What is a pull request? Let's answer this question in this clip. As you know, you have a main branch in your repository, which is your default branch. When you want to develop a new feature, you can create another branch for that new feature. Now, at some point, you might be done with the implementation of your feature. If you work in a team, you would tell your teammates that the feature is done. You might say to one of your teammates, please review this feature and merge it into the main branch if it is okay. Now, let's assume the feature is okay. If your teammate has not yet downloaded your branch, they need to fetch it before they can merge it. So, actually, they need the commands git fetch and git merge to merge your branch into the main branch. Now, as you know, the two commands git fetch and git merge can be executed in one go by using the git pull command. So, you actually requested that your teammate pulls your branch with a new feature into the main branch. Now, exactly for this request to pull your feature branch into the main branch, GitHub supports so-called pull requests. With a pull request, you can say on GitHub, hey, please look at the code in my branch and merge it into your main branch if it is okay. For the pull request, a specific page is created in the repository where you can discuss the feature and the changes. If the repository owner likes the pull request, they can pull the underlying branch into their main branch. If they don't like the pull request, they can also just close it. Alright, so far to pull requests. In the next clip, let's see all of this in action. You will learn how to create and merge a pull request on GitHub. In this demonstration, you will learn how to create and merge a pull request. Let's switch to my command line. Here in our project, let's first call git pull to ensure that we have the latest changes from the remote repository. Now, let's use Notepad to open up the README text file. Let's say you want to implement a new feature, which is adding my GitHub site to this file. So, instead of implementing that feature on the main branch, on which we are currently, let's create a feature branch. So let's use here the git branch command and let's create a branch with the name feature at GitHub. Now I press enter to create this branch and now let's use the checkout command to check out that feature at GitHub branch. Now again, let's open the README text file in Notepad. Now here on this branch, let's add here the GitHub site. I have it already in my clipboard, so let's just paste it. Now let's press Ctrl S to save the README file and let's close Notepad. Now let's type here git status and you see we have modified this file, but it is not staged for the commit. So let's use here git add dot to stage it and now let's create a commit. Let's write here add GitHub to README. And now let's hit enter. This means now when you write git status, you can see you are on this branch and there is nothing to commit, the working tree is clean. Now let's push this branch to a remote branch with the same name. So let's write here git push and let's use our origin remote repository and now I just copy here that branch name and I use it here. So here you define the branch name of the remote repository to which you want to push the checked out local branch. If that branch name does not exist in the remote repository, it will be created. Now let's press enter to execute this git push command. Now the branch was pushed, and you see here already an information that you can create a pull request for that branch on GitHub by visiting this page here. Here you can also see that this new feature Add GitHub branch was created in the remote repository. Now let's clear the screen here and let's go to the browser. Here in the browser, you can see now beside the main branch also that feature Add GitHub branch. So when you click on that branch, you can see that the README file contains here that GitHub link. Up here you can also see an alert to compare and pull request. Let's click on this button to create a pull request. Now you see the pull request wants that you merge this feature branch into the main branch. You can define here a title and you can also leave a comment. Let's write here add Thomas GitHub profile to the README. Now let's click here on the Create Pull Request button. Now you see we are here in the repository under Pull Requests and that request is open. You can take a look here at the commit of that pull request and you see also here which files are changed by this request. You can see that we added here this GitHub line. Now let's go back to the conversation. When you scroll down, you see that this branch has no conflicts with the base branch, so you can directly merge it here from GitHub. But instead of clicking just on this button to merge in our feature branch from this pull request, I want to show you something more interesting. Let's bring up my command line window. Here on the command line, let's type git branch and let's hit enter. You can see we have that feature branch already locally on my machine. So you could actually merge it here into the main branch and then push that merged main branch to the remote repository. Let's do this. So first, let's check out here the main branch. Now let's check this again by calling git branch. As you can see, we are now on the main branch. Now let's merge in that feature Add GitHub branch into our main branch. I press enter to merge this branch and you see Git did a fast forward commit. This means when you run now git status, you can see that your local branch is ahead of Origin main by one commit. So the next step is to push that commit to the remote repository. So here, let's use the git push command. When I execute this, you need to look here at the GitHub website to see what happens. So I press enter. As you can see, the change was pushed and the GitHub website says pull request successfully merged and closed. This means now that the feature branch can be deleted. So first, locally on my machine, let's delete now that feature Add GitHub branch. Now I have only left the main branch on my machine. Now let's go to the browser. As that branch was merged now into the main branch, you can delete that feature branch from the GitHub repository. This means now that when you go to pull requests, you see 0 pull requests are open and we have here one closed pull request, which is this add GitHub to README pull request. Now when you take a look at the code, you can see that the README file contains here the GitHub link. Also, when you look now at the commits, you can see that commit that I created. So now you saw that a pull request is actually a request to merge a feature branch into your main branch. In the next clip, you will learn how another user can make a pull request to my repository here. In this demonstration, you will learn how to fork a repository on GitHub and why you want to do that. Let's switch to my browser. Here you can see our repository that is in my profile. By default, I am the only person who can push changes to this repository. If you want, you can adjust this under the settings of the repository. Here you find collaborators, and you can add new people if you want. Then these people can also push directly to your repository. But now, let's assume someone who is not a collaborator wants to propose some changes for this repository. This means they want to create a pull request. How can they do this when they are not allowed to push a branch to this repository? They can create a pull request by forking this repository. Let me show you now what this means. To do that, let's bring up another browser window. Here you can see the profile of Julia Developer, who is a fictitious dev who loves to write code. As you can see in the top right corner, I'm signed in here as Julia Developer. Now, in the address bar of the browser, let's navigate to our GitHub project. Here, Julia can click on the code button and she could use this URL to clone this repository to her local machine. Then she could work with the local repository, but she is not allowed to push any changes to this remote repository. Now let's assume Julia looks at this repository and she sees here, oh Thomas, he created a README text file. Instead of this, he could use a markdown file that allows a bit of formatting of this text. So she wants to create a pull request that changes the README text file to a markdown file. To do this, she can create a copy of this repository in her profile. Such a copy in GitHub is called a fork. You can see here that this repository has 0 forks. Now Julia can click here on this arrow and she can create now a fork of this repository. Now you see here GitHub says a fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project. It looks pretty much like creating a repository in your profile. You enter here a repository name, which is by default the same as the repository that you want to fork. Then you also get the description of the original repository. Here the option is also selected to copy only the main branch of that repository. Now let's click here on the button Create Fork. Now you see here you are now under Julia Developer, where you have now this Git for Beginners My Project repository. Here you see now that copy. So when you go again to the profile of Julia Developer, you can see now she has this repository which is forked from Thomas Claudius Huber Git for Beginners My Project. Now let's click on this repository to navigate to it. Now Julia can use this URL here to clone this repository into a local repository on her machine. Then she can commit changes locally and she can push her commits to this remote repository. She is allowed to push to this forked repository as this repository is in her own GitHub profile. But now, instead of cloning this repository to change the README file, let's change the README file directly here on GitHub. As you can see, here at the top, you can adjust the file name. So let's change it from README TXT to README MD, which stands for Markdown. Now, besides editing the file, you can also preview the changes here. You see, the document was renamed without changes. So let's go back to this Edit File tab. To define a headline in Markdown, you write a hash before the text. Now let's click again on Preview Changes. Now you see you replaced this text here with this new headline. Now let's also make the other information a bit more readable. Let's go back to Edit File. Let's make actually a list with this author information. To do this, you add a dash before every line. Now let's go again to preview changes, and now you see it looks now like this, which is pretty good. So now look here, you can commit now the changes directly to the main branch of the repository in Julia's profile. The comment here is update and rename readme.txt to readme.md. This sounds good, so let's click here on commit changes. Now you see, this is what the readme markdown file looks now in Julia's repository. Now, when you navigate back to the code of this repository, you can see here that Julia's branch is one commit ahead of the main branch in my repository. This means that she can create now a pull request in my repository for the commit that she created here in this forked repository. To do that, Julia can click here on Contribute, and you see here is a button to open a pull request in the original repository. Now let's click on this button to open a pull request. Here the pull request has the title Update and rename readme.txt to readme.md. Let's enter here a comment. This looks much better in your repository. Now let's click here on Create Pull Request. As you can see, now this pull request is created in the repository of me. It is not in the forked repository of Julia. As you can see, she wants to merge her main branch into the main branch of my repository. In the next clip, you will learn how to merge this pull request. In this demonstration, you will learn how to merge the pull request from Julia. Let's switch to my browser. As you can see here in the top right corner, I'm logged in into GitHub. I'm here on my repository and I've opened this pull request from Julia Developer. She writes here, this looks much better in your repository. She has changed actually 2 files. What's that? She deleted the readme text file and she added the readme markdown file. Here she included markdown code. There is actually this single commit in this pull request. Now let's go again to the conversation. As you can see, the branch has no conflicts, so you can click here on Merge Pull Request to merge it. But again, let's bring up a command line window and let's see how you can do that from the command line. Here on the command line, let's first call git pull to grab all the changes. Our local repository is already up to date. Now let's check the branches by using the A option, which stands for all, so that you can see also remote branches. Julia's branch is not visible here. This is because the branch lives in her forked repository. So now let's just create here a new branch and let's call it Julia-main. Now let's check out the Julia main branch. So let's write here git branch and you see we are now on Julia's main branch. Now this branch was created from our main branch. That means we don't have Julia's changes yet in that branch. So let's go again to the browser and let's click here on that branch. Now you can see we are in Julia's forked repository. Here I click on code and I copy the URL to Julia's repository. Now let's navigate back to our pull request. Let me bring up now again the command line. Here in the command line, let me clear the screen. Now, as you saw, we are on that local Julia main branch. Now let's use git pull and let's use that URL to Julia's repository and let's grab from there the main branch. Now let's hit enter and you see the readme.txt file was replaced with the readme.md file. This means you have now the changes from Julia in your local Julia main branch. So this means you can use now, for example, File Explorer to look at the repository. Now you see, here is a README Markdown file. Let's right-click this file and let's select from the context menu Open with Notepad. Now you see, she has adjusted this file. This change looks good, so let's close Notepad and File Explorer and let's merge that change into the main branch. So let's write again git branch. Now let's check out the main branch. Let's write again git branch and you see we are now on the main branch. Now let's write here git merge and let's use the Julia main branch and let's hit enter. Now you have the changes from Julia in your main branch. So the next step is to just use git push to push up your main branch. Let's hit enter and now let's look at github.com. As you can see now, Thomas Claudius Huber merged commit into Thomas Claudius Huber main. So now this pull request is merged and Julia developer could actually delete her fork. Now let's go again to the code tab of this repository and you see here the new nicely formatted README Markdown file. Alright, now let's wrap up what you have learned in this lesson. You learned in this lesson that a pull request proposes to merge a branch into the main branch of a repository. I showed you how to create and merge a pull request. You also saw how to fork a repository on GitHub. A fork is a copy of someone else's repository. It allows you to create a pull request for someone else's repository. Alright, so now you learned how you can collaborate with other developers on GitHub by using pull requests. Now you have a foundational knowledge of Git and GitHub. In the next clip, let's discuss what's next for you. In this clip, let's see what's next for you. First, I want to say that I hope that you enjoyed this course about Git and that it was worth your time. We used in this course the command line as I think that is the best way to learn and understand how Git actually works. The command line is also the same on the different operating systems. This means you can use your knowledge on any operating system. But now, with your gained knowledge, might be a good time to look also at the graphical user interfaces that exist to use Git. To do this, go to git-scm.com from where you downloaded Git. When you navigate here to downloads, you find here a section that is called GUI clients. Here you find different applications for all major operating systems. Now, important to know is that it's not either a graphical user interface or the command line. You can use the command line and one of these applications at the same time. For some tasks, you might like the command line better, and for other tasks, like for example looking at a branching history, you might prefer a graphical user interface. So I recommend that you try out some of these applications when you work with Git. Alright, that's it. Thank you for watching this course. My name is Thomas Claudius Huber. I'm looking forward to seeing you the next time.